Guys, welcome back to my channel. Now we are going to start the circles part 3, parametric equations of a circle. The parametric equations of a circle with center h comma k are given by x equal to h plus r cos theta comma y equal to k plus r sin theta. Here h and k are the coordinates of the center and r is the radius. Cos theta and sin theta are trigonometric terms that we have to put, and if they ask the parametric point, then you have to the coordinate x comma y, that's h plus r cos theta comma k plus r sin theta. And the second one is equation of chord joining the 2 points theta 1 and theta 2 on the circle x square plus y square equal to r square. X cos theta 1 plus theta 2 by 2 plus y sin theta 1 plus theta 2 by 2 equal to r cos theta 1 minus theta 2 by 2. Now you can get it out. What are theta 1 and theta 2? The theta 1 and theta 2 are the angles subtended to the center with these chords. And if we go to the third one, length of chord AB joining A theta 1 comma b theta 2 on the circle x square plus y square equal to r square is, this can be written as x minus x1 whole square plus y minus y1 whole square equal to r square. Then the length is 2r into modulus of sin theta 1 minus theta 2 whole by 2. This is the length of chord AB joining A of theta 1 comma B of theta 2. I said that what are theta 1 and theta 2. And coming to the fourth point, the equation of chord joining the 2 points theta 1 and theta 2 on the circle at s equal to 0 is x plus g cos theta 1 plus theta 2 by 2 plus y plus f sin theta 1 plus theta 2 by 2 equal to r cos theta 1 minus theta 2 by 2. If you see one thing, a common thing is there in second one and fourth one, but in the place of x and y, x plus g comma y plus f are substituted. If we come to the notation, normal equation of a circle is equal to x square plus y square plus 2gx plus 2fy plus c equal to 0. But if we come to s1, that gives us x into x1 plus y into y1 plus g into x plus x1 plus f into y plus y1 plus c equal to 0. It comes to this s11, it gives x1 whole square plus y1 whole square equal to plus 2gx1 plus 2fy1 plus c equal to 0. This will be the notation of S11. X square plus y x1 square plus y1 square plus 2gx1 plus 2fy1 plus c equal to 0. Now coming to the part of position of a point with respect to circle. Position of a point with respect to circle. Now in this position of point with respect to circle, it tells that if the point P lies inside circle, then P is less than 0. That implies, not P, S11. That implies x1 square plus y1 square plus 2gx1 plus 2fy1 plus c less than 0. And coming to the second case, P lies on the circle. That implies S11 equal to 0, which indicates x1 square plus y1 square plus 2gx1 plus 2fy1 plus c equal to 0. And the third case is when P lies outside the circle, right? When P lies outside the circle, then s11 greater than 0, which implies x1 square plus y1 square plus 2gx1 plus 2fy1 plus c greater than 0. Yeah. Now the equation of the circle passing through 3 points a of x1 comma y1, b of x2 comma y2, and c of x3 comma y3. It shows that we have to use the determinants. x1 x2 x3 y1 y2 y3 1 1 1 into x square plus y square plus c1 c2 c3 y1 y2 y3 1 1 1 into x plus x1 x2 x3 c1 c2 c3 1 1 1 into y plus x1 x2 x3 y1 y2 y3 c1 c2 c3 equal to 0. This is the point when the equation of the circle passing to 3 points a of x1 comma y1, b of x2 comma y2, and c of x3 comma y3 is this. If you solve this, you will get the equation. And coming to the next point, the equation of a circumcircle of the triangle formed by the lines L1 equal to 0, L2 equal to 0, L3 equal to 0 is lambda into L1 L2 plus lambda 1 into L1 L2 plus lambda 3 into L3 L2 L3, that's only L3 lambda 3 into L3 L1 equal to 0, where the lambda 1 comma lambda 2 comma lambda 3 can be found by using coefficient of x square equal to coefficient of y square, coefficient of xy equal to 0, right? Coefficient of xy equal to 0, right? This is the main condition of it, equal to 0. Now coming to the next important topic, the concentric circles. What are the concentric circles? If the two circles are formed at the same center but have different radius r1 and r2, these are called concentric circles. Let's try how to find the equation of concentric circles. Right? Let's take that this inner small circle is A and outer bigger circle is B. Then the equation of A, if the equation of A is x square plus y square plus 2gx plus 2fy plus c, then the equation of B will be x square plus y square plus 2gx plus 2fy plus k. The difference between them is only the constant change, because the change between them is only the radius, so only the change is constant, and k is unknown. It could be any constant, but if you calculate the radius you could find it easily. Next topic is concyclic points. What are the concyclic points? If the points a b c d lies on the same circle, then the points are said to be concyclic points. If the lines a1x plus b1y plus c1 equal to 0, comma a2x plus b2y plus c2 equal to 0 meets the coordinate axis at 4 distinct points, then those points are concyclic points. If these lines form concyclic points, then A1 A2 equal to B1 B2. Coming to the another condition, if the lines A1x plus B1y plus C1 equal to 0, comma A2x plus B2y plus C2 equal to 0 meet the coordinate axis, in four distinct concyclic points, then the equation of circle passing through these concyclic points is A1x plus B1y plus C into A2x plus B2y plus C2, this is C1, minus A1B2 plus A2B1 into XY equal to 0. This is about the concyclic points. Next, if we come to the minimum and maximum distances, let's think that this is the circle S and this is the center C. These are the radius, and a point P is somewhere here. If this point is A, now we have to find the maximum distances between the circle center and P. We have to find it. So the circle set the minimum distance is equal to CP minus R. This would be the minimum distance, and the maximum distance equal to CP plus R. So guys, from these questions you will get 2 to 3 questions in your final exams. So keep watching my videos. Thank you.